The Leatherback. Every recreational scuba certification on Earth caps you around 130 feet, because past that, the water starts doing things to a human body that don't get undone. This animal treats that as the shallow end, and it goes down there without the one piece of equipment every other sea turtle is built around. Leatherbacks are the largest turtles alive, up to about 10 feet long, usually 500 to 1,500 pounds, with the heaviest ever recorded pushing 2,000. They eat jellyfish, almost exclusively, which sounds like easy living until you think about gripping something that slippery. Their throat is lined with hundreds of backward-pointing spines, all the way down. Somewhere along the line, nature looked at the problem of holding on to jelly and went with spikes. Just spikes, forever. Recreational divers tap out around 130 feet. Military submarines start getting nervous past 1,600. A leatherback tagged in the Solomon Islands in 2023 was logged at 4,409. Despite the name, it isn't shellless. Most people picture something bare and unprotected down there, but the shell is still in place, rebuilt as thousands of small bones set into leathery skin, so the whole structure squeezes under pressure instead of fighting it. Nothing rigid, nothing to implode. Its bulk, an oily fat layer, and heat exchangers in the flippers hold its core roughly 30 degrees Fahrenheit above the water around it. Surviving something that should kill you is never free, though. It just means the bill got paid somewhere you can't see. Pacific leatherbacks are critically endangered, and the animal pulling all of this off looks like a ribbed rubber mat with a permanent teardrop. No reptile on Earth has been recorded going deeper. The Hawksbill. There's a reason almost nothing on a coral reef eats sponges. A sponge is reinforced with silica, the same stuff as window glass, and loaded with chemistry that makes most reef fish sick. It's one of the only food sources out there nobody's competing for. And it stays that way because almost nothing can touch it. The Hawksbill built its entire life around it. Sponges make up roughly 70 to 95% of what an adult eats, which makes it the largest vertebrate on the planet feeding mainly on sponges, and the only reptile that bothers. To get at them, it uses a narrow, hooked beak that reaches into crevices nothing else can work, giving it a face like someone attached bolt cutters to a turtle. Its gut handles the glass spicules without the perforation that would follow in basically any other vertebrate, and it processes the sponge's chemical defenses instead of being poisoned by them. But those compounds are fat-soluble. They don't leave. They collect in the turtle's own fat and organs, year after year for its entire life. So picture chewing a mouthful of fiberglass insulation. Now picture that being most of your diet every day for 40 years. Estimates put a single adult's intake north of 1,000 pounds of sponge annually, spicules included. Most people assume tortoiseshell is a pattern or some old-fashioned plastic. It was never either. It was this animal's shell, and the look everyone recognizes is the overlap of its plates, which is a big part of why it sits on the critically endangered list today. So it doesn't just survive the poison, it keeps it. Immunity, out here, is rarely a gift. It's a debt something agreed to carry. The green turtle. Two things reliably kill air-breathing animals in the ocean: running out of oxygen and drinking the water. This one does both on a schedule, and the trick isn't a bigger lung. A green turtle settling in for the night can stay down 4 to 7 hours without surfacing. The human record for holding your breath, with no pure oxygen going in first, sits around 11.5 minutes. And while it's resting down there, its heart can slow to roughly 1 beat every 9 minutes. That's a nap so committed, the heart basically clocks out between checks. It manages that by slowing everything and rerouting blood so a single lungful stretches across most of a night. The salt problem gets a different fix. Behind each eye sits a gland that dumps out a solution about twice as salty as seawater, so every liter it swallows gives back around half a liter of usable fresh water. It's a desalination plant, wired into the eye socket. Somewhere in the design meeting, the answer to salt was just to leak it out next to your face. Adults are the only sea turtles that go fully vegetarian, grazing seagrass and algae, and juveniles don't switch over until around age 3. Which brings up the name, because despite the name, This turtle isn't green on the outside. The green is inside, in the fat and the cartilage, tinted by decades of that seagrass diet. The species is listed as endangered. The name was never describing the outside. If you're into animals that quietly break the rules of being alive, I make videos like this all the time, and subscribing really helps. Thanks. The Loggerhead. Drop a person in the middle of the North Pacific with no instruments, and the outcome isn't really in question. North Pacific loggerheads hatch in Japan, spend years off the coast of Mexico, then go back to Japan to nest. They get it right the first time, with nobody to follow. They aren't tracking anything you'd recognize as a landmark either. The map comes installed, and researchers spent decades arguing about what it's actually made of. Work out of Ken Lohman's lab shows loggerheads learn and remember the magnetic signature of specific places, reading both the strength of the field and the angle its lines meet the Earth at. New York to Los Angeles is about 2,500 miles. Driving the entire perimeter of the lower 48 would run closer to 7,000. A loggerhead named Adelita, the first sea turtle ever satellite tracked across a whole ocean basin, logged more than 9,000 miles in 368 days. Current thinking is that two separate systems run at once. One looks like light-sensitive chemistry in the eye that reads direction. The other seems to involve magnetite, letting the animal feel field intensity directly. Scientists were sure for years there was one magnetic sense. There are two. The common version of the lost years has hatchlings drifting wherever the current drags them, but satellite tracking of juveniles showed they actively swim, leaving currents on purpose to reach the floating weed mats they want. The bill for that map is a childhood spent entirely at sea, with no shore to fall back on. Born with a navigation system it can't switch off, mute, or reroute. And nobody has fully worked out what the turtle is actually feeling when it reads that field. The Olive Ridley. A nesting sea turtle on an open beach is doing the single most exposed thing it will ever do. The Olive Ridley's answer wasn't to hide better. It was to show up with everybody else at the exact same time. The event has a name, Aribada, and it happens at a handful of places on Earth, mainly La Escobilla in Mexico, Ostunal in Costa Rica, and the Odisha coast of India. Females come ashore in synchronized waves over a few days, often in broad daylight, which almost no other sea turtle does. A busy summer beach is a few thousand people spread across miles of sand. An Aribada packs more animals onto one stretch than live in most American towns. The biggest ones put hundreds of thousands of nesting females on a single beach inside a matter of days, until the ones arriving are climbing over the ones already digging. The logic behind it is called predator satiation. When nests show up in numbers nothing local can process, the share of nests that make it through climbs sharply, and all that overlap concentrates mating, and multiplies genetic exchange several times over compared with nesting alone. And if you've seen footage of a nesting female with tears running down her face, most people assume that's strain or emotion. It isn't. Those are salt glands running flat out, and they run whether or not she's anywhere near a beach. What nobody's cracked is the trigger. Decades of study, and the most reliable prediction anyone can offer is still roughly sometime around then. It's the largest synchronized nesting event of any reptile on Earth. Numbers, it turns out, are their own kind of armor. The Flatback. The standard sea turtle plan is to get hatchlings out into open ocean fast, where there's nowhere to hide, but also nothing concentrated hunting them. This one skips that entirely. It spends its whole life in shallow coastal water, which should be the worst possible call. Every known nesting beach for the Flatback is in Australia. Not most of them, all of them. It has the smallest range of any sea turtle, no oceanic phase, and no long migration across anything. Its shell is pressed flat, with the rim turned up around the edges, thinner and waxier than the others, like the design brief just said dinner plate and everybody signed off. The compensation happens before a hatchling ever touches water. A typical sea turtle hatchling is roughly the size of your palm, and light enough that wind shoves it around. A flatback comes out noticeably longer and heavier bodied than that, about 60 millimeters of shell straight out of the nest, the largest hatchling of any sea turtle, which puts it past the size range a lot of shallow water hunters can handle. Fewer eggs, bigger babies, and a start that skips years of unpredictable open ocean food entirely. Here, the bill gets paid up front, in a hatchling too big and too armored to be cheap to make. Most people assume every sea turtle is some globe-crossing migrant. Turns out one of them never leaves its own continental shelf, and it's not the one struggling for it. Honestly, it's the one species that looked at the Great Migration and decided it was fine right where it was. It didn't beat the open ocean. It opted out of it. The Kemp's Ridley. It's hard to protect an animal that science hasn't confirmed is its own species, and for roughly 80 years, that was this turtle's situation. It got formally described in 1880. Nobody confirmed where it nested until the early 1960s. That's 80 years of a well-known animal with no known origin, and people filled the gap in themselves. For decades, it carried the nickname bastard turtle, because with no nesting site anyone could locate, some naturalists concluded it had to be a sterile hybrid of two other species. An entire field decided an animal must be a mistake because they couldn't find its eggs. The answer had already been filmed. In 1947, Andres Herrera shot footage of an arribada at Rancho Nuevo, a narrow strip of coast in Tamaulipas, Mexico, later estimated at tens of thousands of nesting females in a single day. That reel sat effectively unknown until a biologist named Henry Hildebrand tracked it down in the early 1960s and settled the whole question. And the reason nobody found it is the same reason it worked. Packing nearly an entire species nesting onto one short beach in synchronized daylight waves is a strategy that runs on sheer overwhelm. And it also made the species close to invisible to anyone searching anywhere else. The common version of this animal for decades was that it wasn't really a species at all. Genetics and that beach both settled it. It's its own species and always was. A gray olive turtle small enough to fit in a wheelbarrow, and shaped a lot like a hubcap. It's listed as critically endangered, with protection at the nesting beach running since the 1970s. The species had been telling everyone exactly where it was for 80 years. Nobody was standing on the right beach. The Archelon. Around 80 million years ago, a shallow sea cut straight through the middle of North America, and it was full of mosasaurs. Swimming around in it was an animal with roughly the footprint of a small car. Archelon ischiros is the largest sea turtle known to science. The best specimen, pulled out of the Pierre Shale in South Dakota, runs about 15 feet from head to tail, with a flipper span close to 13 feet and weight estimates past 2 tons. A queen mattress is about 6.5 feet across. A compact car is roughly 14 feet long. This was a turtle you'd have to measure in parking spaces. And here's the part that doesn't fit the picture. Its shell wasn't really a shell. Instead of a solid plate, it carried a reduced lattice of strut-like ribs under tough, leathery skin. A solid carapace at that size would have been ruinously heavy to push through water. So the fix was to build the thing like a kite frame and skin it. At that scale, the shell had stopped being the main defense anyway. Being difficult to fit inside a mouth was. Most people assume Archelon is just an older draft of the sea turtles swimming around now. It isn't. Its whole branch left no living descendants, and every sea turtle alive today traces back to a different, smaller line. Every trick in the ocean comes with a bill attached, and for 80 million years, this one paid it in size. The ocean eventually raised the price past what size could cover. The biggest sea turtle that ever lived left nothing behind, and the ocean went to the small ones instead. I put out new animal deep dives every week, so hit subscribe and I'll see you in the next one. Thanks for watching.